Hey. Hey, everybody. Good morning. Let's see here. All right. Whoops. Thank you. Okay, let's kick it off. I am Dr. Phoenix Perry, and I am here to talk to you guys about AI. First of all, I want to say thank you for coming for a 9:30 a.m. talk on machine learning and AI. You have all my thanks. So why me? Why am I here to talk about this? I've been working with interactive machine learning since about 2009, 2010, when I really wanted to think about how to make inclusive interfaces for myself because I have a disability in my spine, and it makes doing a lot of things difficult. And I was interested in ways that I could use gesture and my entire body to interact with computing systems. And that is my journey entry into this. I am now going to tell you a little bit about a project that I love that I'm not talking about today called Code Liberation Foundation, which this is one of our classes in Brooklyn, New York. And my goal here is to liberate, empower, and positively transform culture through technology. We teach women and non-binary individuals to program video games to tell their stories for free, and we've taught around 20,000 people worldwide. Okay, so since it's 9:30, 10 o'clock in the morning, I'm going to run down some helpful terms that I'm going to cover in my talk. So if anything I talk about is confusing and you want to learn more about this, I'm an educator, so you can come find me after my talk. But I'm going to go down these kind of terms I'll be mentioning in my discussion. So data. Data is really something I think a lot of people don't understand, but it's digital input that can be stored like photos, audio, or numbers. It can also be a ground truth or a way to communicate ideas. A data set is just collection of that data. A folder on your computer full of pictures of your best friends, that's data. An Excel spreadsheet, also data. Now, this is where it gets a little contentious. Machine learning systems. I think a lot of people hear learning and they associate that with human learning. I want to kind of clarify here that that's not what a computer does. Algorithms that statistically analyze data sets and improve performance without explicit programming are what programmers consider machine learning. So it's literally just a couple lines of math doing weighting with the output going into the input. It is not intelligence. AI includes machine learning as one of its many approaches. However, they're often conflated. So you'll hear people talk about AI and then machine learning in the same phrase, and you don't really know the difference of those things. They are completely different. One is just one approach within the larger space of AI. Generative machine learning. If you've seen DALL-E or any of the things that you've kind of run across in media recently, you've seen generative AI. This is a trained system where the outputs are similar to the data set that the system was trained on, and when the users input some sort of data, it goes into its data set and generates something similar to the data set it was trained on. Latent space. I'm only going to mention this once, so don't be too afraid. But it's a representation of compressed abstract features learned by a machine learning model which captures the underlying structure and variability of the input data. So when you're making a machine learning system, you tell it to pay attention to certain features. Like maybe you want to pay attention if you're training it on music, for example. Pay attention to the gaps between songs. Pay attention to the high notes and the low notes. These things are called feature extractors, and they become the kind of features that this system is looking for. And if you're going to be playing with the latent space, you're playing with some of the parameters of those features. Human-in-the-loop learning. In my opinion, this is really critical, and this is a good way to make AI. It's a process where after the machine learning system outputs what it's going to put out, a human actually reviews that, and then the system learns from what the human says is a good result. So it's human-in-the-loop learning. Interactive machine learning is my favorite thing. I love interactive machine learning. It's a type of machine learning that involves active human input, feedback, and guidance during the training process. Bias. We're talking a little bit about bias, but I'm going to surprise you in how I talk about it. This is when a data set lacks sufficient information or contains disproportionate information. So for example, you have trained your entire photo library on pictures of cats, and then you ask it to generate a tree, it's going to generate a cat, right, in the shape of a tree. And this can lead to skewed or very irrelevant results. Some of the AI you've seen that's gone a little off the rails usually is a result of the data set being weighted in one direction or the other. So I'm going to break down some mythologies, and the first myth I'm going to go and talk about is generative AI systems improve with big data. Right now, we're all being convinced to surrender tons of information about ourselves under the idea that generative AI is going to make our lives easier. Bigger does not equal better. There is a belief that bigger data sets are going to lead to these better AI outputs, but is this good art? Like, really? Do we think this is good? Because I don't think this is very good. I think this looks pretty hokey and cheesy. And my question is, better for whom? What future are we building with this? So creative machine learning may have different goals, and creators may have different ways of working that can be better served by an idea called small data. Artists can benefit from working with smaller, curated data sets and open models that are trained on their own images, and they generate work that reflects an authorial intent. This is Follow the House of Usher by Anna Ridler, and she trained a data set on her own drawings and then used the Pix-to-Pix model to render out film stills in the style of her own art. This is another piece of hers I really like called Circadian Nocturne. You can download on your phones if any of you want to play it. This quote from her, I think, really says it all. The control that comes to me in this process really comes from what I do with the data set. This is another piece called Autonomies of Intelligence, and it's by artists Joanna Chakao and Jonathan Roos. And they employ live coding to investigate their custom data sets. So they've built this big collection of data that includes different things that they want to talk about philosophically in the work. And then they have a machine learning algorithm designed to specifically work with that data that they're controlling. So they combined ideas from early Enlightenment era anatomy with machine learning to create a performative, dissective, embodied artistic method. And it's an amazing piece. And they show, when they're live coding, they show the inside of the machine learning system live to allow for a participatory, performative exploration of the materials.
The anatomist and the anatomized body. Iteration over iteration, calculating distances, cutting across various lengths, performing a series of dissections, cutting through corpses, data, our anatomical data set collection. Classified objects of knowledge, a new collection is born. Paradoxically, is also a manner in which to gain access to knowledge.
So artists can curate and interact with model inputs and outputs. So properties like photorealism can become less aesthetically and philosophically relevant. This is a kind of screenshot of the piece that I just showed you. And what I love about this is in real time, they code this live, and they talk about the process of opening up and dissecting these machine learning systems, and they make an analogy to this kind of Enlightenment era. And while at the same time, they're kind of debunking this idea of Cartesian Enlightenment. And I find this piece really moving. By exploring the data through embodied engagements with data set via custom interfaces, new understandings of that data can become present. They also made these inflatable sculptures that they let the audience lay on, and while they were manipulating the data and the system, they could feel the object moving beneath them. This is a project that I made in 2010 called Black Swan, and this is an interactive machine learning system running inside Unity with Ableton Live, and my friend and collaborator on this project, Rebecca Feebrink, her interactive machine learning system, which is open and you should all try, called Wekinator, code-free for those of you who are non-programmers in the room. And when I was working with this, it really let me feel what my data set was, in this case, my own music and my own 3D images. And I gained a sense of performing with this. And what that meant is I could feel where the dips and holes in my data were in new ways. When creators can actively engage with and manipulate data and models, they can steer the AI system towards more expressive and contextually relevant outputs. Smaller data translates into less work for creators who want to curate data sets. This is a project from a group called datasets, and these musicians focus on generating music, which is from tons of more niche genres, such as math rock or black metal, and they're really after looking for these ultra-long, progressive sections, textural rhythms, and aggressive rhythmic attacks. And they pre-process their own data into 8-second chunks, and they use a 2-tier sample recurrent neural network, which recurrent neural networks are, ask me later. But this is a very small. My point of this is they run this on their own computer over 3 days. They don't need a ton of electricity. They don't need a massive server farm. They do this themselves on their own computer. They emphasize the aesthetic merit of the imperfections in the generated music, liking it to creative explorations of vintage sound production techniques. The generative music retains the timbre of the original bands, but exhibits novel characteristics such as odd time signatures, abrupt sectional changes, and atmospheric textures.
One, two, three, four, five.
The why it is for
1, 2, 3, 4, 5.
enough for Peter Brosem as listen. And for with VDM and this expression just
So simpler architectures capable of being trained on small data sets can be trained faster, often in real-time context, allowing for the space of live performers to train and interact with machine learning, like we just saw. They're also sustainable and manageable. This is a project by Gabriel, and everything I'm showing today is from a paper that Rebecca and I wrote called Small Data. The small data mindset. And Gabriel does a really cool thing where he puts one machine learning system on top of the other to play with the latent space. And he creates a music generator from a very small data set of maybe a dozen or so examples, trained on a very specific small genre. He uses the data representation to allow for him to take rhythms from many, many cultures. He's a Latino man living in Brazil. I think actually just moved to Canada, but he provides this kind of live performance by navigating these 2D representations of latent space in real time. So dare I do it? I'm gonna let you hear some of Gabriel's music. Or not. You guys can find Gabriel. Anyway, you can play with his live tool here. If any of you are interested, I'm gonna post the talk that I'm giving right now on my Twitter, and I'll give it to the FutureDays folks. So if you guys want to get the links and the citations, they're here for you later, okay? But this is open software that lets you play with the latent space. So, but what about bias, right? What about bias? In one sense, the bias is inherent in small, manually curated, well-understood data sets, and that can be desirable. When a creator is employing a data set as a medium for communicating an idea to the machine, they can better control the outputs they generate. No data is neutral. This is a mythology. Data always tells a story. Critically ask yourself, who benefits from discussions around universal data sets, and what are you asked to be surrendering to achieve it? Requiring large data sets introduces its own form of bias in what we are limited to modeling and the phenomena that can be easily represented with large amounts of data that can be easily sourced, like text, photos, and images. This is a project from Mimi Anoha, who's an artist that I really like, a data scientist as well. And this is their library of missing data sets. And they've collected data sets that are just not missing. They're just not available, and they're missing for political reasons, because data always tells a story. What is publicly available gun trace data? That doesn't exist. And there are projects now to attempt to capture some of this data, because who's capturing your data and who's storing your data, they have a political agenda to what they're doing. Who can host and build these massive data sets? Very large language models like ChatGPT or GPT-3, GPT-4, Switch-C, they've been trained on large, not properly curated, static dumps from the web. And this is a question of being unregulated or stolen data.
So videos on YouTube?
Hang on. Wait.
She's being
That is
asked
not
what
a good
Sora
face
was
to
trained
make.
on. So
You say, sir, do you have any stolen art in your art collection? And the guy's like, well, not sure. All I know is whatever she says from here, I'm very skeptical of.
And licensed data.
So videos on YouTube?
I'm actually not sure about that.
Okay.
she's the
What?
CTO.
Isn't that your job, to be sure about where the data's coming from?
Videos from Facebook, Instagram?
You know, if they were publicly available, publicly available to use, there might be the data, but I'm not sure.
Yeah.
I'm not confident about it.
Now, from the get-go, when I saw this, I wondered to myself, is this person media trained? I mean, I think the right answer here is just I'm not going to answer that question. When you say, I don't know, it comes off very, like, self-incriminating. And I think it would have just been better to say, like, we're not going to talk about that. It's, as she...
The details of data.
I'm
for
gonna
them
attempt
possible
to,
data and use
can
it
you
to train
guys
their
just
models
go
and then
forward on the next slide?
Meanwhile, the whole point and lying to you.
Oh,
And the
they asked
evidence
me
for
to
this
send them a Google
open-
Sheet doc. I'm sorry, guys. But anyway, you can see this, right? You can see why this is a problem. She's like essentially confessing in this video that they scraped your Instagram and Facebook to make Sora. That's terrifying. That means every picture that you've posted for your grandma who's on Facebook is in Sora, and that is a problem to me. These generative models like Jukebox, which is OpenAI's music generator, were trained on more than 1 million songs, half of which are in English, and they have a heavy bias towards mainstream music genres, making it difficult to use with more niche genres. When data sets are small, or even one change or 2 or 3 changes, such as the addition or removal of a few training examples, can have a big impact on the model's behavior. Large data projects often face challenges in accurately modeling the movements of disabled individuals. This is primarily due to the limited representation of disabled people in the dataset used to train these models. Moreover, developers frequently prioritize and design for what they perceive as their most lucrative target audience, inadvertently excluding and overlooking the needs of other groups, including those with disabilities. However, 80% of all people are going to experience disability in their lifetime. That's a massive, massive demographic. What kind of tools empower equitable, small data, open source creative work? Okay, shameless interactive plug. This is Interactive ML. If you work inside Unreal, this is my free open source machine learning plugin for artists and creators that requires no programming at all. Additionally, I'm going to show you a little bit of it working, and then I'm going to show you how I make it possible to edit and control your own data inside the software. Oh, we're at the beginning. Can you jump towards the end for me where the semaphore demo is? It's labeled in the video. It's going to happen about here.
As the player moves around, you can...
Keep going, keep going. This is regression. Bingo! Yeah, semaphore. Perfect. Thank you. So this is Gibson Martelli.
Okay, so this is the semaphore test environment, which is actually to teach you how to do semaphore, and we've just started developing this. So there's you can see there's a mirror that's in front of me, which has the semaphore flag positions. I've got my semaphore flags in my hand, and on the left there's like a little tile, and the tile gives me the output. So this machine learning system has been trained with all the letters, so I'm hoping that I can actually spell out words and things like that. So I'm just going to start with the alphabet, and I'm just going to run the system now. So it's going to give me A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and then Q, and then R, E.
Oh, okay, perfect. Maybe next slide.
There's something that's emerging right now.
This is definitely. Next slide, please. Thanks, guys. So anyway, did you guys see what was going on there? It was a set of letters that Bruno had trained on his own body with his own ability to make these gestures. What this means is that anyone who wants to build or record an interface based on whatever gestures or input they can get into the system, it totally works. So inside Unreal, you can open up the example data and you can edit it in the engine. And to me, this is really important. Like, I want people to be able to edit, see, and control their data and understand what it means when they delete just one example from their data set. How does that train the system? What I really want to do now is I have a bunch of ideas on how to open source collective data sets. And this leads me to disability-led AI design. I believe there's space in this tool to create a sign language database. It's something I really want to do. It's a dream project of mine. It's going to require a collective commons because there's very little interest from VR developers to create multiple languages of sign language. But if we had a data commons where people who signed could just record that data and share it, signing in VR would just be a solved problem. Cool. So this leads me to disability-led AI design. This is my friend Louise Hickman. Here, this is it.
This means that my work looks at the space between code and people and all their lived experience. How can disability change the way we write code? To understand this question, I'm going to take you back to the 1970s. We're going to meet a professor of cybernetics, somebody who looked at the communication between machines and living things. His name was Gregory Bateson, and one day he asked his students in his class to consider a blind person walking with their cane. He asked his students, where did the blind person's self begin? The person's brain, their hand, the tip of their cane? By asking these questions, Bateson is drawing attention to the feedback loop between the blind person, their cane, and their environment. Who is doing the navigating? The cane, their body, the brain, grip of the cane, or the actual path of travel? In effect, Bateson debunks the idea that the brain is processing data about the environment, but instead, we are looking at the purported feedback loop. It's shaped by the environment, our bodies, and the ideas that we have about our bodies. Algorithm and AI are similar to the blind person's cane. They do not work alone, but they are part of an ever-changing environment. And the question for this feedback loop. Here, I'm resisting the idea of algorithm as a coherent set of code that follows.
So creators know that materials and tools matter. We know that. The material is the data set in the machine learning system when we're working with AI. We understand that tools shape our minds. And this all stems from a theory called material engagement theory, stemming off what Louise just talked about. Our cognitive processes are not limited to the brain, but they're distributed across our brain, our body, and the material world around us. Objects and systems are not passive instruments, but active agents in shaping human biology, understanding, and culture. And we've proved this scientifically now. Artifacts and technologies embody cultural knowledge and mediate social interactions, enabling the accumulation and transmission of cultural information across generations. In this way, we're just starting to understand AI. AI is not going to evolve. We are. I'm Dr. Phoenix Ferry. All right, that's it. I'm getting off this stage.